Previously, I just threw some numbers in here to make up some different portfolios to give us some spread on the chart. But if you think about it, for any given return, let's say we were seeking a 10% return, we'd much rather have this portfolio than this portfolio because we get the same return expected for a lower risk. Similarly here, we'd much rather have this one than this one. So we could go through here and say for any given return, what portfolio would minimize our risk? And that's an optimization question. Kind of sounds like GoalSeek, but GoalSeek won't work here. We need Solver. So if you don't have Solver, go to File, Options, Add-ins, Excel add-ins, click Go, and make sure that the Solver add-in is checked. When you do so, and you go to the Data menu, then you'll see Solver here. When you click Solver, this is your GoalSeek screen on steroids. It will let us maximize and minimize our objective function instead of just setting it equal to a certain value. It will also let us change more than one cell at one time because we're going to need to be changing all three components of our portfolio, and it will let us set constraints. We need to set the sum of these numbers equal to 100%. Let's create a column to show the sum of the weights of the portfolio, and we can use that as a constraint. If I cut that and do an insert cut cells, then it will just move everything over to the left. The chart will still be looking at the columns in their new positions. So let's try this once. I like the first portfolio because it's all Kellogg, the next one's all Exxon, and the third one's all Walmart. The fourth one though, let's just delete some of these numbers. In fact, let's set them to 33, 33, 34. And let's put a description up here. For this fourth portfolio, let's find the point on the plot that gives us the absolute lowest risk. Let's say we're very risk averse and we wanted the minimum variance portfolio. We don't say minimum standard deviation portfolio, even that's what we're doing here. Variance is just the square of the standard deviation. That's just what we call it, the MVP, the minimum variance portfolio. So let's go to Solver and say we want to set the risk of this portfolio in cell S6 to a minimum value by changing all three of these cells, and we want to add some constraints. We want the sum of those cells to equal 1. In fact, that's the only constraint we're going to add for this one. And when we say solve and OK, we see that it popped up this point down here. And so no matter how hard we tried, we could never get a risk lower than 7.2% standard deviation. That one is 3/4 Kellogg and about 1/4 Walmart to get the lowest standard deviation. Surprisingly, ExxonMobil doesn't even help you get a lower standard deviation according to our optimization. The next point that might be interesting would be, what if we wanted a little bit higher return? Let's say we wanted an 8% return, and whatever the minimum risk that would be. So let's go to Solver and say set our risk to a minimum. In this case, we're working on row 7. We'll go down to this next portfolio. Let's go ahead and label it, in fact. Let's say min risk at 8% return. So to find the portfolio that gives us the minimum risk at 8% return, we need to minimize that portfolio's risk by changing that portfolio's makeup of the 3 stocks, subject to the constraint that the sum of those three stocks is equal to 100%. And the return of that portfolio is 8%. And then when we solve for the portfolio, the 33, 33, 34 changes to 61, 8, 31, and we get this point up here, which is the minimum risk at 8% return. So any other combination of portfolios at 8% return would be out here somewhere. Nothing would be to the left. We're going to continue this process. Let's do it again one time, walk through it for 10% return, and then I'll turn off the sound and do this quickly for the rest of the efficient frontier. So for 10% return, we're going to go back to Solver. And this time we're going to say minimize the risk here in cell S8 by changing the makeup of the portfolio in PQ and R8, subject to the constraints that the sum of PQ and R8 is equal to 1. And the return on this portfolio, let's do one at 10% here. And when we solve, we should get a point to pop up on that 10% line. Apparently I did something wrong. S8, PQR8, I said change everything about the portfolio on row 8 subject to a constraint on row 7. So it said that doesn't work. So let's change that row 7 constraint to 8 and make sure that the return in T8 is equal to 10%. Now when we solve, we get a point to pop up on the 10% row there, over here. We'll accept it, and now we can see what distribution of our money across those three stocks would give us a 10% return and the minimum risk at that return. I'm going to do a couple of more portfolios here to fill out the efficient frontier. Notice that I got tired of using the mouse and I just came in here and realized we were going down one row at a time. So I can change the 10 to an 11 and then change that return from 13 to 14. So we've done a pretty good job of building out the efficient frontier. I've got a gap in my envelope down here, so I'm going to do one more point at 5%. And what I'm left with is the efficient frontier, what I'll call the inefficient frontier, or the other half of the envelope. And then 1 point on here for Walmart stock, 1 point on here, excuse me, that was ExxonMobil, Walmart, and Kellogg. It looks like Walmart stock is part of the efficient frontier. Your highest returning stock always will be part of the efficient frontier. It'll be the riskiest point on it. And then your lowest returning stock will be the bottom point on the envelope. Any stocks with returns in between the lowest and the highest probably will not fall on the efficient frontier or the envelope at all. And the reason I keep using this term efficient frontier, just a review, is that it's the most efficient way to get a given return. I can get a 4% return with about 14% standard deviation. But for that same risk, I could get over a 10% return. That's much more efficient. That's why we call anything from this point up to this point the efficient frontier.